So when I say operating system, what pops into your head? Probably Windows, right? Or maybe Mac OS. But what if I told you there's a whole universe beyond those familiar names? A world built on freedom, transparency, and some seriously cool ideas. Today, we're diving deep into the architecture of freedom, the amazing world of open source operating systems. All right, here's our game plan. First, we'll nail down what open source actually means. Then, we'll take a tour of some incredible specialized systems. We'll see how they're used for learning, and then wrap it all up by looking at the big picture, the pros and the cons. Sound good? Let's get into it. So, let's start with the most important question of all. What does it actually mean for an operating system to be open source? You hear this term thrown around all the time, but the idea behind it is incredibly powerful. Here it is, the secret sauce. It all comes down to the source code, the actual blueprint of the software. With a proprietary OS, that blueprint is locked away in a vault. But with open source, the blueprint is out there for everyone to see. You can look at it, learn from it. Heck, you can even change it and share your improvements with the world. And this slide just lays it out perfectly. It's the difference between a locked box built by one company and a massive public library where a global community of developers are all working together. It's a totally different way of thinking about how software is made. Okay, so now that we know what it is, let's see what you can do with all that freedom. Because when anyone can build their own OS, you get some fascinating, super specialized tools. We'll start with one that takes a look back in time. First up, let's hop in the time machine with FreeDOS. This OS has one main mission, keeping the software of yesterday alive and kicking on the computers of today. Now you might be asking, why would I need this? Well, think about all that old-school business software or those classic games that just won't run on modern systems. FreeDOS is their lifeline, and because it's so incredibly lightweight, it's also perfect for small, simple embedded systems. It's a real workhorse. All right, now let's slam the accelerator and jump from the dusty past right into the heart of the modern cloud. Meet OSV, an operating system built from scratch to do one thing and do it better than anyone else: run stuff in the cloud. The key here is its laser focus. OSV is ruthless about minimalism. It throws out everything it doesn't need. Drivers for a keyboard or a monitor? Nope. In a cloud server, they just don't exist. It's designed to run just one single application inside a virtual machine, making it insanely fast and efficient. This is absolutely perfect for the modern world of microservices. Okay, so we've seen some specialized tools, but now we're going to get into the really wild stuff. This is where developers use that open source freedom to completely rethink what an operating system can even be. These are fundamentally different. Say hello to Genode. Now this isn't just an OS, it's more like a set of super secure building blocks. It's a framework for building systems where security isn't just a feature you add on, it's baked into the absolute foundation of everything. Now, to really get Genode, you have to wrap your head around this concept of a microkernel. Imagine the core of your OS as a tiny, super protected vault. In a microkernel, only the most critical stuff runs inside that vault. Everything else, drivers, file systems, you name it, runs outside as separate programs. In that modular design is Genode's superpower. If one part crashes, say your graphics driver has a bad day, it doesn't take the whole system down with it. That's a huge departure from traditional Unix-like systems. For anything where security and stability are absolutely critical, this is a total game changer. All right, if you thought that was different, brace yourself. This is Phantom OS, and its core idea is, well, it's kind of mind-bending. The whole system is built around this concept of persistence. What if your computer never actually forgot anything? I mean, just let that sink in for a second. You reboot your machine, and when it comes back on, your applications are right where you left them, still running, as if nothing ever happened. It's like your computer has a perfect memory. This is all thanks to its persistent memory model, and it's a completely different way to think about how software works. So, beyond building these specialized tools and wild new architectures, the open source world is also one of the greatest digital classrooms you could ever ask for, and our next example is proof of that. Meet Cosmos. Now look, you're probably not going to install this to check your email. That's not the point. Cosmos is an incredible toolkit, a playground, that lets you build your own operating system from scratch using a really popular language, C#. And that's the magic, right? It's all about accessibility. OS development has always been this really low-level, kind of scary thing. Cosmos blows that door wide open for a huge community of developers, letting them learn about the very heart of how a computer works. It's fantastic.
Wow, we've been on quite a journey, from running old DOS games to systems with persistent memory. So let's pull back and look at the big picture. What are the real-world trade-offs of going down the open source path?
This table really ties everything together beautifully. You can see it all at a glance. You've got FreeDOS, the lightweight legacy tool, OSV, the hyper-focused cloud specialist. Then you have Genode with its microkernel security, and Phantom OS with its mind-bending persistence. And notice this last column, most of these are not based on Unix. That's a huge takeaway. It shows how open source lets people build brand new foundations to solve problems, not just tweak what's already there.
The advantages are pretty amazing. First, the price is often zero. Can't beat that. You can customize it to do exactly what you need. There's usually a massive global community you can turn to for help, and security is a big one. With the code being public, more eyes can find and fix problems. Plus, you're never locked in to a single company's ecosystem. But, and there's always a but, right? That freedom comes with responsibility. You can't just call a 1-800 number for help. You're probably going to need a bit more technical know-how. You might hit some bumps with hardware compatibility, and let's be honest, some of these are experiments. It's the classic trade-off between total control and out-of-the-box convenience. And that leaves me with one final thought for you. We've seen operating systems custom-built for the cloud, for high security, for running old tech, for learning. So as our needs get more and more specific, is the future of computing a single